This is the first 9 weeks exam review. Numbers 1 and 2, the directions say evaluate each expression. That just means that we want to simplify anything we can using the order of operations in this case. So on number 1, we know that we want to handle any grouping symbols, which we think of as parentheses, but really parentheses, that's going to be brackets, braces, and on number 2, we're going to think of that fraction bar as a pair of grouping symbols. Then we want to do any exponents we see, then multiplication and division. Keep in mind multiplication and division happen in the same step from left to right, and then addition and subtraction in the same step from left to right. So parentheses, well, inside parentheses we see 6 minus 2, so we'll say 6 minus 2 and get 4. So 3 times 4 minus 2 times 3. So we've done parentheses. We don't have any exponents in this problem. Multiplication and division. When we see multiplication in 2 places, 3 times 4 is 12, and 2 times 3 is 6. So we've done multiplication and division. Addition and subtraction. Well, we do have subtraction, so 12 minus 6 gives us 6. So we've simplified that as far as we can and gotten 6. On number 2, again, we want to think of this fraction bar as a grouping symbol. That just means we want to simplify everything on top by itself and simplify everything on bottom by itself before we think about dividing anything. So on the top, we're going to handle order of operations, which means that we're going to multiply first. 7 times 2 gives us 14. So on the top, we have 3 plus 14 plus 8. So if we simplify all of that, again, then we just have addition in 2 places. So 3 plus 14 is 17. 17 plus 8 is 25. On the bottom, all we have is 5 times 3. So 5 times 3 gives us 25, or 15. 5 times 3 is 15, so we end up with 25 over 15, which if we reduce that, it will reduce to 5/3. So 5/3 on number 2. Numbers 3 through 6, the directions also say simplify each expression. In this case, we have variables. So we need to keep in mind that when we are simplifying expressions with variables, we can only combine terms that are like terms. That means we can only combine terms that have the same variables and exponents. So on number 3, 7n and n are like terms. We can add those. 7n plus n is 8n. We can't add the 3 to it because the 3 is not a like term with 7n and n. On number 4, we have the distributive property that we need to do first. Once we've done that, 11 times a is 11a. 11 times 4 is 44, so 11a plus 44. Then we also have the 3a and the plus in the front. Once we get to that point, again, we need to only add the terms, add or subtract the terms that have the same variables and exponents. Well, 3a and 11a are like terms, so when we add those, we get 14a, and then we just have plus 44. So 14a plus 44 is as far as we can simplify number 4. On number 5, we have the distributive property that we're also going to need to use. So we're going to multiply, we're really not the distributive property, we just have 9a times negative 4b. Well, if we multiply that, we get negative 36 AB. Again, we can't combine those, so we just say negative 36 times A times B. Well, then we have another spot with multiplication. 3z times negative 6b. We'll multiply the numbers and get negative 18. And then zb, well, we'll put those alphabetically, so we'll do bz. Okay, so once we get to this point, now we're going to handle the addition. Well, these aren't like terms because they don't have the same variables and exponents, a, b, b, z. So all we can do is to clean this up a little bit in the middle. Instead of writing plus negative, we'll just write that as minus. So again, don't be tempted to just combine all of the terms into one big term. You can only add or subtract terms that have the same variables and exponents. On number 6, we can say 3 times 2a and 3 times b. 3 times 2a is 6a. 3 times b is 3b, so minus 3b. When we do the distributive property on the second part, we're going to treat that minus in front of the 2 as a negative when we distribute. So negative 2 times 4a is negative 8a, which we'll write as minus 8a. And then negative 2 times 3b is negative 6b, so minus 6b. Once we get to that point, we'll combine terms that are like terms. The 6a and the 8a are like terms because they have the same variables, and the 3b and minus 6b, we can combine those because those have the same variables. Well, 6a minus 8a, that's negative 2a, and negative 3b minus 6b is negative 9b, so minus 9b. So number 6, the farthest we can simplify that is negative 2a minus 9b. These are not like terms, so they cannot be combined any farther. On numbers 7 and 8, we are dealing with matrices, and we are given a matrix A and matrix B in our instructions. What we need to remember is that we are going to do order of operations even when we're dealing with matrices. So number 7, it says that we're going to multiply matrix B by 4 and multiply matrix A by 2, and then we're going to subtract. Again, we're going to multiply here and multiply here before we subtract. So 4 times matrix B, that would look like this. 4 times the matrix that they called B in our instructions. Minus 2 times matrix A. Well, matrix A we have given to us in our instructions also. And then we will simplify using the order of operations. Again, just like anything else, if we're dealing with matrices, if we're dealing with variables, if we're dealing with just numbers, we're always going to follow the order of operations. That means that we're going to use the order of operations to multiply here and multiply here before we subtract. Well, when we multiply a matrix by a single number, really what we're doing is we're just distributing the number in front to every part of the matrix. And when we multiply a matrix by a single number, our result is a matrix of the same size and shape that we started with. 4 times 8 is 32. 4 times negative 6 is negative 24. 4 times 0.2 is 0.8. 4 times 4 is 16. 4 times 11 is 44. And 4 times 0 is 0. When we multiply the other matrix, 2 times each part of the matrix. Again, it's just like distributing that 2 to every single term inside the matrix. And what we're going to get when we multiply a matrix by a single number, that's called a scalar, then we are going to get a matrix of the same size and shape. 2 times negative 5 is negative 10. 2 times 4 is 8. 2 times 9 is 18. 2 times 0 is 0. 2 times 2 is 4. And 2 times negative 3 is negative 6. At that point, we need to subtract those two matrices, and we know that if we subtract two matrices, our result is going to be a matrix that is the same size and shape. 32, we're going to subtract the terms that are in the same spot of each matrix. So we have 32 in the top left, so we're going to subtract that by negative 10, which is in the top left. When we do that, we're going to get our answer that's in the top left. 32 times negative 10 gives us 42. 0.8 minus 8 gives us negative 7.2. 44 minus 18 gives us 26. Negative 24 minus 0 gives us negative 24. 16 minus 4 gives us 12. And 0 minus negative 6 gives us positive 6. So on number 7, our solution would be this matrix. Again, be sure to use order of operations even when dealing with matrices. On number 8, we're going to do the same thing. It's a little simpler though. All we're doing is taking matrix B and multiplying it by the scalar of negative 3. So negative 3 times matrix B would look like this when we write it out. We've already said if we multiply a matrix by a single number, which we're calling a scalar, this would be a scalar, then we're just going to get a matrix that's the same size and shape. So negative 3 times 8 gives us negative 24. Negative 3 times negative 6 is positive 18. Negative 3 times 0.2 is negative 0.6. Negative 3 times 4 is negative 12. Negative 3 times 11 is negative 33. And negative 3 times 0 is 0. So that's our solution for number 8. Number 9, it says matrix B is the result when matrix A is multiplied by a scalar. Well, we have to know what that word scalar means. Again, a scalar just means a number that we are multiplying an entire matrix by. So these numbers that I've underlined on numbers 7 and 8 are called scalars. So we're wanting to know what we had to multiply each of the parts in A, matrix A, by to get our result in matrix B. Because it says in the problem, matrix B is the result when matrix A is multiplied by a scalar. Well, what do we have to multiply 3 by to get negative 6? What do we have to multiply negative 12 by to get 24? Well, most of us can do that in our head and think, well, 3 times 2 is 6, so to get a negative, it has to be negative 2, so our scalar is negative 2. But if we don't know that, then let's think about it like this. We know that we're going to multiply something out here. We'll just call it x. We'll multiply matrix A by this number to get matrix B. So really, 3 times x equals negative 6. So let's set up that equation. 3x equals negative 6. Divide the left by 3, divide the right by 3, and we end up with x equals negative 2. We should get the same thing if we do any of the numbers in matrix A. 15x should equal y. So once we know that our scalar is negative 2, then we can look at the question that it asks us on number 9. So again, we know that the scalar has to be negative 2 because negative 2 times 3 is negative 6. Negative 2 times negative 12 is positive 24. Negative 2 times negative 24 is positive 48. So it's wanting to know, number 9, what y has to be. Well, negative 2 times 15 is going to give us negative 30. So y has to be negative 30 on number 9. Number 10, it says matrix W shows the cost of shirts and pants from 3 different manufacturers. Write a matrix that shows 0.07 W plus W, the total cost of each item, including its 7% sales tax. So it tells us basically that we want to take matrix W, which is this matrix, and put it in place of W everywhere we see W in that expression. So what that would look like is 0.07 times all of those amounts up there, $59.99, $29.99, so on and so forth. And once we get our resulting matrix of when we multiply it by 0.07, then we're going to add the matrix W to it again. And that solution is there for you on the answer to the answer key to your exam review that I gave you in class. Number 11, it says analyze the graph at the right. Write a sentence that describes what is happening to the temperature as time passes. Well, it looks like on our y-axis we have temperature. On the x-axis you have time. As time passes, it looks like the temperature is going up and then it's leveling off. So the sentence that you could write, it doesn't have to look exactly like mine, but I would say the temperature slowly rises, then levels off. Something to that effect. Or the temperature rises and then remains constant. And let's look at number 12. On numbers 12 through 15, we are using formulas to solve each of these problems. So this is where you'll want to have your formula chart handy. On number 12, it says find the circumference of a circle if its diameter length is 12.6 centimeters. Well, we know that the circumference formula of a circle is either, well, it says on our formula, let's go with the formula on our formula chart. Circumference equals 2 pi times the radius. Well, we know that if the diameter is 12.6 inches, that means the radius is half of that. So if we divide 12.6 by 2, then we will get 6.3 inches is our radius. So in this problem, then we need to say 2 times pi, which we'll call 3.14, times the radius, which is 6.3. So when we multiply all of that together, then we will come up with our answer somewhere around 39.56 inches. So that would be the answer to number 12. All right, on number 13, we're finding the area of a triangle. So we have a formula for that. So anytime you are given a problem that's involving a shape, I recommend drawing the shape. That's going to help a lot of us out. So on number 13, I'll draw the triangle. It looks like this. Find the area of a triangle if the length of its base is 7 meters, so I'll label this 7 meters, and its height is 10 meters. Well, we know the height is just the distance, the perpendicular distance from one side across to the opposite corner. So the height here would be 10 meters. So we'll use our area formula for a triangle, which on our formula chart it says area equals base times height divided by 2. Well, the base and the height are given to us in the problem. 7 times 10 divided by 2, that would be 70 divided by 2, which is 35. Our units in the problem are meters. So we know when we're talking about area, we're going to have square units. So square meters on number 13. On number 14, it says, suppose that the area of a rectangle is 45 square feet. If its length is 9 feet, then what is its width? So on number 14, we know that we're dealing with a rectangle, so you might want to draw a rectangle. Doesn't have to be pretty. And we know that the area is 45 square feet. It tells us that the length is 9, and we want to know what the width is. Well, we know that the area formula of a rectangle is area equals length times width. We're going to fill in any information we know in that formula at this point. The area, it tells us in the problem, is 45. The length is 9, and the width we don't know. Well, that looks like a one-step equation that we can solve. We'll divide the right by 9 and the left by 9. The 9 divided by 9 cancels, so we get W on the left, or on the right-hand side. On the left-hand side, we get 5. We know that our units, again, in this problem are feet, so the width is going to be 5 feet on that problem. On number 15, where you're going to be using the distance formula, it says that Nikki is traveling from Hattiesburg to Atlanta. The length of the trip is 320 miles. If she travels 4 hours at 50 miles per hour before stopping, how many more miles will she have to travel once she gets back in the car? So be sure on this that you are answering the question that it asks. Don't just say how far she's traveled. Answer how many more miles does she have to travel. So we know that the distance formula is distance equals rate times time. It tells us in the problem that she goes 50 miles per hour, so that's the rate for 4 hours. So if we multiply that, then we'll get what D is. So our distance that she has traveled is 200 miles. So she's traveled 200 miles. We know that she wants to go 320 miles. So if we subtract how far she wants to go by how far she's gone, we'll get 120 miles that she still has to go. So our answer to number 15 is 120 miles. On number 16 and 17, it says write an algebraic expression for the perimeter of each figure drawn below. Well, looking at number 16, this is a rectangle, and we have a perimeter formula on our formula chart that says that the perimeter of a rectangle is 2 times length plus W. Or we can just think of the perimeter of a rectangle as the sum of all of its sides. That's how I prefer to think about it. 4x and 4x minus 1. If this is a rectangle, then we know that this other side has to be 6x and the top side has to be 4x minus 1. Well, we know that perimeter just means the distance around all of the sides added together. So we just need to add up the like terms. So in this problem, we're going to add 4x plus 6x plus 4x plus 6x. When we do that, we get 6x plus 6x is 12 plus 8 is 20x. And then the minus 1 and minus 1 are like terms. Well, negative 1 minus 1 is negative 2, so 20x minus 2 would be our expression that represents the perimeter. Same thing on number 17. We're going to add the parts that are like terms, 2x and x and 3x. That's 2x plus 1x is 3x plus another 3x is 6x. And then minus 5 plus 13 plus 2. Well, negative 5 plus 13 is 8. 8 plus 2 is 10, so 6x plus 10 would be our perimeter for number 17. On numbers 18 and 19, it says write an algebraic expression for the area of each figure drawn below. Well, on number 18, we know that the area formula of a rectangle is length times width, and we're given the length and width of this rectangle, so we'll say 3 times 7x minus 8. It is important that I put the 7x minus 8 in parentheses, because we know that if we don't, then we would only be multiplying part of the width by 3, and we want to multiply the entire width by 3. So 3 times 7x and 3 times negative 8. 3 times 7x is 21x. 3 times negative 8 is negative 24. So 21x minus 24 would be the area of that rectangle. Now, number 19, it's not specified, but this is similar to that problem, the problems that we've seen this year where you're finding the area of the shaded region. Well, on this problem, if I want to find the area of the shaded region, it looks like what we would need to do is find the area of the entire big rectangle and then subtract the area of the two smaller shapes that are not shaded. So again, I'm going to write that out in words. Area of rectangle minus area of circle minus area of triangle. So I want to find the area of all three of those and then subtract the two smaller ones, the circle and the triangle, from the rectangle. So area of a rectangle we know is length times width. Well, 7 times 15, if we multiply 7 and 15, then we are going to get 105. So the area of that entire rectangle is 105. So then let's find the area of the other two. Area of a circle we know is pi r squared. Well, the radius of that circle is 2, so 3.14 times 2 squared. Well, 2 squared is 4, so 4 times 3.14. The area of that circle is 12.56 square units. Then the area of the triangle, we know the area of a triangle is base times height divided by 2. The base and the height are 3 and 4, so 3 times 4 divided by 2, which is 12 divided by 2, or just 6. So the area of the entire shape, that all of that together, is 105. If we subtract the 12.56 units minus the 6 units, then we should get 86.44 square units. So again, anytime you're dealing with a shaded area problem, find the area of the entire shape and then subtract the parts that are not shaded. Then let's look at the next problem, number 20. It says, consider this cylinder. Write an expression that represents its volume if the measure of its radius is tripled and the measure of its height is cubed. Well, when we look at the volume of a cylinder, we know that we want to find the area of the base times the height. So volume is going to be the area of the base times the height. Well, we want to know the volume if the measure of its radius is tripled and the height is doubled. So instead of 2y, we want 4y, and instead of 4, we want 12. Again, we just tripled the radius and doubled the height. Well, area of the base, that's going to be pi times radius squared times the height. So pi we know is 3.14. The radius, we just changed it from 4 to 12. So 3.14 times 12 squared times the height, which is 4y. Well, 12 squared is 144. So 3.14 times 144 times 4y. And if we multiply all of that together, then we should come up with 1,808.64 y units. So 1,808.64 y units. Again, we doubled the height, made it, instead of 2y, we made it 4y. And instead of 4 for the radius, it said we wanted to triple that. So we multiplied it by 3 and got 12. Well, volume is area of the base times the height. Area of the base is pi r squared times the height. And then we just filled in our measurements that we knew and evaluated that. So that's number 20. Numbers 21 down to 28, we're solving equations. Some are one-step, some are multi-step equations. So numbers 21, 22, and 23. On 21, we want to get x by itself. X has been multiplied by 5, so we'll divide the left by 5 and divide the right by 5. Once we've done that, the 5's cancel, and we get x on the left, and we get negative 9 on the right. On number 22, we want to always use the distributive property on both sides to get rid of any parentheses that we have first. So I'm going to distribute the negative 5 on the left. That will give us negative 5p minus 15, and we have the 8 in front. And then on the right hand side, we want to use the distributive property. 3 times 7p is 21p. 3 times negative 1 is negative 3. So then our equation looks like that. At that point, we want to combine any like terms that we see. 8 minus 15. Well, those are the only like terms in that problem that are on the same side of the equal sign. 8 minus 15 gives us negative 7, so negative 7 minus 5p equals 21p minus 3. At that point, we want to get rid of the variable term on either the left or the right because we have p's on both sides. So I'll get rid of the negative 5p by adding 5p to the left and to the right. The 5p's cancel on the left. So we end up with negative 7 equals 26p minus 3. And then we want to add 3 to the left and to the right because we're wanting to get p by itself. We need to undo the subtraction first and then undo the multiplication. The 3's cancel and we end up with negative 4 equals 26p. And then since p has been multiplied by 26, we'll divide the right by 26 and divide the left by 26. The 26's cancel and we get p on the right. On the left, negative 4 over 26 can reduce down to negative 2/13. So p is going to be negative 2/13 on that one. On number 23, this is a little more basic than the last problem. We want to get the x by itself. We have something added to the x, and we have something, and the x has been multiplied by something. So we want to kind of do the order of operations backwards. We want to get rid of addition first, and then we'll handle the multiplication. So minus 2 to the left and the right, the 2's cancel. We end up with 3x equals 21. Since x has been multiplied by 3, we need to divide the left by 3 and the right by 3. The 3's cancel and we get x equals 7. So number 23, x is going to equal 7. Let's look at 24, 25, and 26. Again, our very first step is to get rid of any parentheses that we see. We don't see any on 24. The step after that is we want to combine any like terms on either the left-hand side or the right-hand side. There aren't any like terms on the left or the right. The next step is we want to get rid of the variable term on either the left or the right. I'll get rid of the ones on the left. The 6z's are going to cancel when we subtract 6z. So we end up with negative 14 equals z minus 5. And then we'll add 5 to the right and to the left. The 5's cancel and we get z on the left. And we end up with negative 9 on, or z on the right and negative 9 on the left-hand side. On number 25, we don't have any parentheses to deal with. We don't have like terms on the left. We don't have like terms on the right. So what we want to do is we want to get rid of the variable term on either the left or the right. I'll get rid of the 5.19y on the right by adding 5.19y to both sides. The 5.19y's cancel on the right. On the left-hand side, we end up with 8.49y plus 2.15 equals negative 0.84. At that point, we're trying to get y by itself, so I want to get rid of whatever's been added to it. I'm going to subtract 2.15 from the left and from the right. The 2.15's cancel, so on the left-hand side, we end up with 8.49y. On the right-hand side, we need to subtract those two. Negative 0.84 minus 2.15 gives us negative 2.99. At that point, we want to divide the left by 8.49 and divide the right by 8.49. When we've done that, we get, if we round that to the, we'll just round it to the hundredths place, we'll get negative 0.35. So I would specify on the test where to round that problem to. And then on number 26, we have 3 times w equals negative 14, so we'll divide the left by 3 and the right by 3. The 3's cancel, and we get w equals negative 14 thirds. I'm just going to leave it as a fraction, negative 14 thirds. You could write that as a decimal, but we'll just leave it like this. And then our next problems on numbers 27 and 28, we are going to be dealing with some fractions on those. So on number 27, the way that we've thought about this problem, instead of b divided by negative 7, some of us are multiplying both sides by negative 7, which is fine. But just for the sake of consistency, the way that we've handled some of these other problems, we're going to think of b over negative 7 as 1b over negative 7, and then we're going to bring the coefficient out in front, negative 1/7 b on the right-hand side. On the left, we have negative 11. So now we're thinking about this as a multiplication equation. We have negative 1/7 times b, so we're going to divide the left by negative 1/7. And once we've done that, negative 1/7 cancel on the right, and we get b on the right. On the left, if we divide negative 11 by negative 1/7, I'm just going to put the negative 1/7 in parentheses if we're typing that in a calculator, and we get b equals positive 77. On number 28, we have 1/3n plus 3/4 equals 5/6n minus 1. Well, we want to get rid of the variable term either on the left or the right. I'll get rid of the one on the left this time by subtracting 1/3n from both sides. The 1/3n's cancel on the left, so what we're left with is 3/4 on the left. On the right hand side, 5/6n minus 1/3n. Well, that's like 2/6n, so we get 3/6n, or let's call that 1/2 n minus 1. Again, we subtracted these, put our fraction in simplest form, and we got 1/2 n. At that point, we're trying to get n by itself. We've had something subtracted from it, so I'll add 1 to the right and to the left. The 1's cancel on the right, so we get 1/2 n on the right, and on the left-hand side, this is like 4/4, so we would get 7/4. At that point, we would divide the right by 1/2 and divide the left by 1/2, and the 1/2's cancel. And we end up with n on the right-hand side. On the left, 7/4 divided by 1/2. When we've divided that, we are going to get 7/2. So 7/2 is what we're going to get for n on 28. On number 29, we are given an equation. It said that she has solved it and she's made a mistake. And we want to see where she's messed up. It says find and correct the mistake that Kelly made when she was solving this equation. Prove that your solution is correct by checking your answer with a graphing calculator. So what we want to do is, first of all, we're going to distribute the 2 times 4x and 2 times negative 3. So they show 2 times 4x minus 2 times 3. So they're good up to that point. Then they actually multiply these together. 2 times 4x is 8x. 2 times 3 is 6. So then we end up with 8x minus 6 equals 6x minus 34. We're good up to that point. But then we want to get either rid of the 8x or the 6x. Well, that's the way we've been thinking about it, but it looks like they've decided to either get rid of the minus 34 or the minus 6. So they decided to get rid of the minus 34 on the right. They added 34 to the right, and they've added 34 to the left. So that's fine. They decided to do that again to get rid of the minus 34. Once they've done that, these should cancel. And when we combine these like terms on the left-hand side, we should get 28. So it looks like they're good up to that point. But here, we're wanting to get all of our x's to one side. We have 8x on the left and 6x on the right. So they decided to subtract the 8x from the left. But it looks like we'll need to also subtract the 8x from the right. Again, if we subtract 8x from the left, we have to subtract 8x from the right. So what we should have gotten once we did that is these would cancel and we would get 28. And then we would get 6x minus 8x on the right. We would get negative 2x. Divide the left by negative 2. And when we do that on the left, 28 divided by negative 2 is negative 14. So if they had subtracted the 8x instead of adding the 8x, we would have gotten that x was negative 14. So the line that they messed up on was line 5 on number 29. On numbers 30 and 31, what we're doing is solving for the indicated variable. So in this case, it says to solve those two equations for x. We know that we've solved our equation for x when x is by itself. Well, it looks like x has been multiplied by a, and then the entire term by has been added to it. So what we want to do first, again, just like if this was an equation with just numbers and a single variable, is if we've had something added to our variable, we want to subtract that term from our variable. So we're going to say minus by on the left, minus by on the right. The by's cancel. So on the left hand side we have a times x. On the right hand side we have c minus by. Then x has been multiplied by a, so we'll divide the left by a, and we'll divide the entire right hand side by a. The a's divide to give us 1, so we end up with x on the left. We end up with c minus by over a on the right. So the x is by itself, so we know that we have solved that equation for x. And then number 31, again, we're trying to solve for x. X has been multiplied by m, and b has been added to it. So our first step is to subtract b from the right and subtract b from the left. So once we've done that, we have y minus b on the left. The b minus b cancels on the right, so we get y minus b equals mx. Well, then x has been multiplied by m, so we need to divide by m to get rid of it. Divide the right by m, divide the left by m. The m's cancel on the right, so we get x on the right. On the left, we get y minus b over m. So the solution to number 31 is this. On numbers 32 and 33, the directions say to write an equation and then solve it. So let's look at those. 4 times a number minus 2 times the same number is equal to 100. So let's set that up. 4 times a number, that would be like 4n, minus 2 times the same number, so that's going to be minus 2n, is equal to, so equals 100. Well, we know that we need to combine like terms if they're on the same side of the equal sign. 4n minus 2n is going to give us 2n. 2n equals 100, and then if we divide the left by 2 and the right by 2, then we end up with n equals 50 on number 32. Number 33 says the cell phone company charges customers $30 for their basic plan, that means no matter what, plus an additional charge of 5 cents for each minute. We said if we see the word each, we're thinking we're going to be multiplying most likely. So 5 cents for each minute of airtime used. If the cell phone bill totaled $55, how many minutes did the cell user did the cell user use their phone this month? So we're going to say that the total is going to equal the base charge plus the rate by minute. So the total is going to be the base charge of the $30 plus the rate by the minute. So the total in this problem was $55. The base charge was $30 plus 5 cents per minute. So that's, we're going to say 0.05 times the number of minutes. Well, if we solve that equation, once we've gotten this set up, the hard part should be just getting it set up. When we solve that, we're going to see that they talked on their phone for 500 minutes that month. So again, we set up the equation. I didn't solve it for you, but that's a two-step equation we need to solve, and then we would get 500 minutes on number 33. Looking at the back page, it says solve and graph each inequality. 34, 35, and 36, we are just dealing with a regular inequality. Keep in mind that 34, 35, and 36 are going to be handled differently than 38, than the problem starting on 38, 39, 40, 41, because down here, this section, we are looking at absolute value, which means that we might end up setting up two equations or two inequalities depending on what type of number we see on the right-hand side of our equation or inequality. So 34, we have an inequality, and we're going to solve this exactly like we solved a regular equation, but if we divide both sides by a negative or multiply both sides by a negative, then we need to flip this inequality symbol. So on 34, we'll subtract 5 from the left and from the right. The 5's cancel, and we get negative 4b is less than negative 28. Again, we're not flipping it because we didn't divide by a negative. But in this step, we need to divide we need to divide the left by negative 4 and the right by negative 4. The negative 4's cancel, and we get b on the left. We get positive 7 on the right, but since we divided by negative 4, we need to flip the sign from less than to greater than. So b is greater than 7. Well, I'll put that on the graph down here. We have 7. Since we have just greater than, it's not greater than or equal to, I'll have an open dot, and I'm going to shade all of the numbers that are greater than 7, which are going to be all of the numbers to the right of 7 on a number line. Then let's look at 35. Well, we need to think about this just like an equation. I'll distribute the 4. 4 times x is 4x. 4 times negative 2 is negative 8, so minus 8. And then plus 6 is less than 2x minus 8. We'll combine like terms on the left-hand side. Negative 8 plus 6 is negative 2, so we have 4x minus 2 is less than 2x minus 8. At that point, we have variable terms on both sides, so I'll get rid of the 2x on the right and the 2x on the left. The 2x's cancel on the right, and we get 2x minus 2 on the left is less than 8. Then we'll add 2 to the left and 2 to the right. The 2's cancel, and we end up with 2x is less than 10. Divide the left by 2, divide the right by 2, the 2's cancel, and we get x is less than 5. Again, we never divided by a positive or a negative number, so we didn't need to flip the sign. Let's check back over that and make sure that we didn't do anything wrong there. 4 times x is 4x. 4 times negative 2 is negative 8. Plus 6 is less than 2x minus 8. We combine these to give us negative 2, so 4x minus 2 is less than 2x minus 8. Again, I want to get rid of the x's on the right, so I subtract 2x from both sides. So 4x minus 2, we add 2 and get 10, and we get x is less than 5. I believe that I have a different answer than you do on your study guide. So either I'm making a careless mistake twice looking back over this, or the answer on your study guide might be wrong. Let's check over this one more time. 4 times x is 4x. 4 times negative 2 is negative 8. Plus 6 is less than 2x minus 8. Oop, there's my mistake. We should have a negative here, so we should have a negative here. So negative 8 plus 2 isn't going to be positive 10. It's going to be negative 6. When we divide negative 6 by 2, we don't get positive 5. We get negative 3. So x is less than negative 3. When we put that on a graph, I'll put negative 3. And since there's not a line underneath the symbol, and it's underneath the inequality symbol, that means that point is not included in the set of numbers that is part of the solution to that inequality. So we'll have an open dot, and it says less than negative 3, so we'll shade all of the numbers that are less than negative 3, so all of the numbers over here. And then number 36, we have 3x minus 11 is less than 3x plus 16. I'll get rid of the x's on the left this time. Minus 6x on the right. Minus 6x on the right, minus 6x on the left. 6x's cancel. 3x minus 6x is negative 3x minus 11. Then we'll add 11 to the left and add 11 to the right. The 11's cancel, and we get negative 3x is less than 27. At that point, we'll divide the left by negative 3 and the right by negative 3. The negative 3's cancel. We get x on the left. We get negative 9 on the right, but we divided by a negative, so we need to flip the sign from less than to greater than. At that point, we will put that solution on a number line, and it just says we want to shade all of the numbers that are greater than negative 9. So we'll draw we'll label it with negative 9 on the number line with an open dot. We know that because there's not a line underneath. And then we'll shade all of the numbers that are greater than that, which are going to be all the numbers to the right of the negative 9 on the number line. Looking at the next problem, it says Jack made a mistake when solving this inequality. Find and correct Jack's work. So we start off with an inequality. We need to distribute the negative 4. So negative 4 times x, negative 4 times negative 8 is positive 32. So it looks like we're good up to that point. Then we need to get rid of the 32. So since we had plus 32, we have to say minus 32 and minus 32. So that looks good. So negative 4x. After these cancel, we just have negative 4x. Negative 10 minus 32 is negative 42. But then it looks like we need to divide the left by -4, and we need to divide the right by -4. The -4's cancel, giving us x, so that's good. -42 divided by -4 gives us positive 10.5, but we divided by a negative, so our sign is going to need to flip. So line 4 is the line where he made the mistake, and the correct answer should be x is less than or equal to 10.5 because we divided by a negative on that problem. And then let's look at number 38. On number 38, we have an absolute value equation, or absolute value inequality. So we know that our very first step is to isolate the part inside the absolute value bars. So if there's anything on the outside of it, in this case the -14, our first step is to get rid of that. So we're going to add 14 to the left and to the right. The 14's cancel, and we end up with the absolute value of y minus 2 is greater than 25. All right, once we've gotten to that point, our next step, and a lot of us weren't catching this last time, is once we've gotten the part in the bars by itself, the next step is to look to the number on the right. If it's a positive number, we're going to set up two equations or set up two inequalities. If it's a negative number, then it's going to be a special case. It's either going to be no solution or all real numbers. Since we have a positive number, we know that we need to set up two inequalities. The first one is going to be exactly as it appears without the bars. Y minus 2 is greater than 25. The second one is going to be y minus 2, and we need to flip the sign from greater than to less than, and instead of 25, we're going to do negative 25. Then we need to solve those two inequalities. We'll add 2 to the left and to the right. The 2's cancel, and we get y is greater than 27. When we solve the other one, plus 2, the 2's cancel, and we get y is less than negative 23. Okay, so once we get here, once we get to the point where our absolute value expression is by itself, this sign shows us where to shade. If it's greater than, then we're going to shade outside. We're going to shade to the outside of the two numbers that we graph. So y is greater than 27, y is less than negative 23. So I'm going to label those two points on the number line, negative 23, 27. We just have greater than signs, so those are open dots, and then we're going to shade on the outsides with arrows on the end. Number 39 looks like this. We have 3 times the absolute value of 2x minus 1 is less than 15. Our first step is to get rid of the 3 on the outside by dividing the left and the right by 3. The 3's cancel, and we get the absolute value of 2x minus 1 is less than 5. Look to the number on the right. We see a positive 5. That means, just like on the last problem, we're going to set up two inequalities. We're going to set up 2x minus 1 is less than 5, and we're going to say 2x minus 1 is greater than negative 5. So two things we changed, the inequality symbol and the number that came after the inequality symbol. At that point, we'll solve for x. We'll add 1 to both sides. The 1's cancel, and we get 2x is less than 6. Divide the left by 2 and the right by 2, and we end up with x is less than 3 on the left-hand inequality. And when we do the same thing to the right, the 1's cancel, and we end up with 2x is greater than negative 4. Divide the left by 2 and the right by 2. The 2's cancel, and we end up with x is greater than negative 2. So when we got to the point up here where we got the part in the bars by itself, we can look to this symbol and know where we're shading. If it's less than, we're shading in the middle or in between. So I said less than, little, in the middle. So we want to shade between those two numbers. So we need to label negative 2 and 3 on the number line. Negative 2, 3, we're going to have open dots again because we didn't have lines underneath. That means that those numbers were not included in the solution set, and then we'll shade in between. So it would look like that. On numbers 40 and 41, we're going to do the same thing. We need to first get the part inside the bars by itself, and that's our starting point. So on number 40, we want to get rid of the minus 5 by adding 5 to the left and the right. The 5's cancel, and we get 2 times the absolute value of x plus 3 is equal to 14. Divide the left by 2 and the right by 2, which makes the 2's cancel, and we get the absolute value of x plus 3 equals 7. At that point, we are going to look to the number on the right and see what kind of number we have. If we have a positive 7, that tells us that we need to set up, in this case, two equations because we have an equal sign. Our first equation is going to be exactly as it appears there without the absolute value bars. And our second equation is going to be x plus 3, and then instead of it being equal to 7, it's going to be negative 7. Again, the reason is when we take the absolute value of either a positive 7 or a negative 7, we're going to get a positive 7. So at this point, we'll solve those two equations, subtract 3 from both sides, and we end up with x equals 4, and x plus 3 equals negative 7. We'll solve that by subtracting 3 from both sides. The 3's cancel, and we get x equals negative 10. So on that problem, we got two solutions. We'll put those solutions on a number line. And in this case, since it's just an equation, we're not going to shade anywhere. We're just going to label and then put a dot on the mark for that label. Negative 4, or negative 10, and positive 4. Put a dot on each of those. And then on number 41, well, number 41, the part inside the bars is already isolated, but if we look to the right, we're going to see a negative number. If we have a negative number, it's a special case. What we need to do is to consider if we have a true statement or if we have a false statement. Well, this is a negative number, and we know that when we take the absolute value of anything, we're going to end up with either a positive number or 0. So at the very least, the part inside the absolute value bars is going to give us 0. Well, are the positive numbers less than negative 14? No, all the positive numbers are greater than negative 14. Is 0 less than negative 14? No. So this statement is always a false statement. So if we have a false statement, then we know that our answer is going to be no solution. And there was a problem like this on the test today, and it said explain the solution of your inequality. Well, the answer was no solution, but what does that mean? That means that there is not a number that we know that we can put in place of k that is going to make the left-hand side of the inequality less than the right-hand side. So number 41 is no solution. On number 42, we are dealing with an absolute value equation again, but it adds one additional little twist. Well, on number 42, we have something outside the absolute value bars, so that's got to be our first step, is to get rid of this minus 1 on the outside. We do that by adding 1 to the left and the right. The 1's cancel, and we get the absolute value of x plus 2 equals 20. All right, well, we have a positive number over here, so we know that we need to set up two equations. X plus 2 equals 20, and we need to do x plus 2 equals negative 20. We'll subtract 2 from both sides. These cancel, and we get x equals 18. And we'll subtract 2 from both sides, and when we do that, we end up with x equals negative 22. So our solutions are 18 and negative 22. The directions say find the product of those. If we find the product of those, that just means we need to multiply 18 times negative 22, and when we do that, we end up with negative 396. So our solution to number 42 is negative 396. On number 43, it says the life expectancy of a butterfly can be described by this inequality. And then it gives us the inequality, where x describes how many days a typical butterfly will live. What is the approximate range of the number of days that a butterfly will live? So on number 43, it's a word problem, but it sets up the inequality for us, and basically we just have to solve that inequality because it says that the solution to that inequality tells us the range of a butterfly's life. So if we solve that inequality, we know that first of all we need to get anything outside the absolute value bars away from the absolute value bars, but we don't have anything, so it's already isolated. So we need to set up two inequalities. So our first inequality is going to be x minus 30 is less than 5. Our second inequality needs to be x minus 30 is greater than negative 5. Then we need to solve those two inequalities. We'll do that by adding 30 to the left and to the right. The 30's cancel, and we get x is less than 35. And then we'll do the same thing over here. Plus 30 plus 30, the 30's cancel, and we end up with x is greater than 25. So we end up with x is less than 35, but x is greater than 25. So our answer then, if we're talking about the length of a butterfly's life, we would say that it is between 25, and 35 days. On number 44. Number 44, it says Brown's Kayak and Canoe Rental charges customers $7 initially for renting a canoe plus $2.50 per hour of use. What is the greatest number of hours you can rent a canoe and not spend more than $17? So we need to set up an inequality here. Again, but I know it's an inequality because it says the greatest number, and if I see greatest or least or anything like that, we know that we're going to be dealing with an inequality. So Brown Kayak is charging $7 no matter what. If you rent it for 2 minutes or if you rent it for 2 days, $7 initially plus $2.50 per hour. So we know that the amount that we're going to be spending, first of all, it needs to be less than or equal to 17. And we know that we have the initial charge, I'm going to abbreviate that IC, plus the hourly charge has to be less than or equal to $17. Well, the initial charge we said was 7 plus the $2.50 per hour, that would be $2.50 times H, has to be less than or equal to 17. Well, if we solve that inequality, we do that by subtracting 7 from the left and the right. The 7's cancel, and we get $2.50 times the number of hours is less than or equal to 10. At that point, we need to divide the left by 250 and divide the right by 250. The 250's cancel, and we get H is less than or equal to 4. So you could rent that up to 4 hours. And then finally, number 45, it says find the value of X, Y, and Z, X, Y, Z, and W that are needed to make this matrix equation true. So in this equation, it says one matrix plus another matrix equals this third matrix. Well, we know that to get each of these numbers in our solution matrix, that we had to, in this case, since it's an addition equation, we had to add the two terms of the two matrices that are in the same position. So to get 6, we had to add, since 6 is in the top left, we had to say top left plus top left equals top left. So if I want to know what X is, well, 4 plus X has to equal 6, so we can set up that equation. 4 plus X equals 6. Then solve the equation and we'll know what X is. Minus 4 on the left, minus 4 on the right. The 4's cancel and we get X equals 2. See if that makes sense. 4 plus 2 equals 6. Well, that makes sense. So let's do the next equation. We know that Y is right here. Since that's in the top right, let's do something with the numbers in the top right to try to figure out what it has to be. Well, to get negative 2, we know that since negative 2 is in the top right corner, we know we had to add the other two terms in the top right corners. So negative 8 plus Y has to equal negative 2. So then we'll solve that equation for Y by adding 8 to both sides. And when we do that, we get Y equals 6. See if that makes sense. Does negative 8 plus 6 equal negative 2? It does. Let's do the same thing for Z. Z is in the bottom left. So we know that bottom left plus bottom left has to equal bottom left, which is 7. So we'll say 3 plus Z equals 7, and then solve that. We'll say minus 3 on the left, minus 3 on the right. The 3's cancel, and we get Z equals 4. We'll check that. 3 plus 4 equals 7. That works out. That makes sense. Okay, and then finally, W is in the bottom right-hand corner. So we know that we have to do bottom right-hand corner plus bottom right-hand corner to equal bottom right-hand corner. So negative 2 plus W has to equal negative 3. Solve that equation for W by adding 2 to the left and to the right. The 2's cancel, and we get W equals negative 1. See if that makes sense. Negative 2 plus negative 1 equals negative 3. That does make sense. Negative 2 plus negative 1 is negative 3, which is what we have here.